Hi everyone. We are going to cut into the abdominopelvic cavity. We've already cut into the thoracic cavity and looked at things like the heart, lungs, trachea, larynx, and esophagus, and the thymus and thyroid. And now we're going to look at what's in the belly, the abdominopelvic cavity. I'm going to make my cut around the umbilical cord. We'll see why in a minute. Around the umbilical cord, back medially, up through there, and do the same thing. I'm going to turn it in the opposite direction. Again, I want to cut superficially. You can see I'm pulling the skin up so I don't cut too deep. I want to keep the organs that are deeper intact. I'm going to open up the skin so it comes out like a door or a window. I've made a little cuts on the liver here. It's not a big deal, but go. You can see that the umbilical cord is right here, and there's some blood vessels leading to the liver. This is the start of fetal circulation from the mother umbilical vein to the liver of the pig. This piece here is called ligamentum teres, or it will become ligamentum teres after the pig or human is born. But right now it's the umbilical vein. And I just cut that. What separates the abdominal cavity from the thoracic cavity is a muscle, a very thin, flat muscle. And that's this muscle right here. This is the diaphragm. This thin, flat muscle here is the diaphragm. It's the important muscle for breathing. If you have when we normally breathe, when we do quiet breathing, it's with the diaphragm. If we breathe deeper, whether it's inhaling or exhaling, it's with other muscles as well. But the diaphragm, major muscle of breathing. All right, so I've got one side mostly open here. I want you to notice that I've accidentally, and it's okay, but I've accidentally cut this tube here. This cut open tube that continues down here, there it is. This is the urinary bladder. So this is what's storing urine, and this will of course empty out during urination, micturition. So I'm going to cut this too, just so it gets out of the way. I'm cutting a little bit of our diaphragm so we open up a bit more. And now on the other side. Whoops, liver or intestines. Here's more of that diaphragm. This is more of that diaphragm. I'm going to cut it. All right, we have our abdominopelvic cavity open. Now we want to look at some specific organs. The biggest one, the most apparent one, is the liver. It's your largest abdominopelvic organ, one of your largest organs. Really important for a bunch of things, from digestion to detoxification to creating really important proteins for your blood. The liver has several lobes. It has 4 lobes, and you can see two of the large ones here. 1, 2, and there's actually a third one here. But the fourth one's hiding back here. Our livers have 4 lobes too, but they're not quite shaped like this. If you lift up the liver, well, let me back up. One important thing the liver does is produce bile for digestion. Bile is this greenish substance that's needed to emulsify fats, to emulsify lipids. The term emulsify means to just mix up and make smaller. So the liver produces bile. It stores it in the gallbladder. And if you lift up the liver, you can see this raisin-looking thing. That is the gallbladder. In the upper right quadrant of the abdominopelvic area, this is the gallbladder. And you can see that the gallbladder will secrete out. This tube will go down all the way to the duodenum, hiding back here, to the duodenum of the small intestines. So we'll take a look at that small intestines later. But the gallbladder, green raisiny looking thing underneath the liver in the upper right quadrant. In the upper left quadrant, we can see this weird extension here that kind of looks like a liver, but it's really tiny and flappy. This is the spleen. The spleen is an organ important in the immune system. One major thing that it does is it breaks down old red blood cells. This is the spleen. Whoops, I tore it a little, but that's okay because I pointed it out already. I'm going to cut the spleen out to the side so we can see other stuff. If we lift up the liver, we can find this big pouch here. This is the stomach. Very, very soft. You'll notice how the spleen is pretty dense. It's soft but dense. The liver, of course, is very dense. It's soft but dense. The stomach is very soft. Dense, soft. This is dense. The liver is dense because it has reticular connective tissue as part of it. Same as the spleen, and we'll see the kidney as well. The stomach does not have that. One similarity between the liver and stomach is that they're covered by a membrane. So you'll just have to believe me that there's this very, very thin membrane that's encasing all of this. The membrane that's covering the liver, the stomach, and most of the intestines is called the peritoneal membrane. The peritoneal membrane is much like the pericardial membrane or the pleural membrane. They are serous membranes. They're meant to lubricate. Our abdominal cavity organs in our abdominal cavity move around a lot, and we want to lubricate these, minimize friction as they move around so that we minimize damage. You can see the stomach here, spleen just to the left of it. If we lift up the stomach, it's behind the membrane, and you can see I can cut some of this membrane here. Behind the membrane, behind the peritoneal membrane, is the pancreas. This grainy looking organ here is the pancreas. Both the pancreas and the gallbladder secrete into the same organ, the duodenum, which is hiding back here. Here's the duodenum, the first part of the small intestines. Both the pancreas and the gallbladder secrete into there. The pancreas, you may know, is an endocrine organ. It produces insulin, which is important for taking sugar into your cells, and glucagon, which is important for releasing sugar into your bloodstream. But it also produces important enzymes for digestion. That's why it's secreting into the small intestines, into the duodenum. The pancreas, I said, is behind the membrane, so it's retroperitoneal. There's that some of that membrane. The pancreas is retroperitoneal. So is the duodenum. The stomach is not. It's intraperitoneal. What I want to do now is cut the stomach out. We want to look inside the stomach because it has some really interesting features. So here's its connection with the duodenum. I'm going to cut that. And then, so that's at the tail end of the stomach. The stomach is also connected to the esophagus. This is where it gets food. And you can see that the stomach is connected at the top here. So I'm going to make a cut here. There's the esophagus. All right, let's cut some of that connective tissue out. And we've removed our stomach. Once again, you can see here, this is the superior part of the stomach, inferior, right lateral, left lateral. This is where the esophagus ends and the stomach begins. This is where the stomach ends and the duodenum begins. There are 4 regions of the stomach. The first part, where the esophagus is coming in, this is called the cardia. It's the heart of the stomach. This bulgy part is called the fundus. This main part is called the body. This last part here is called the pyloric part. Pyloric part. What we're going to do is cut open the stomach so we can see what's inside. It does have some fluid here, so we're going to drain that. I'm going to cut it open like a book. I'm going to cut from the esophageal part to the duodenal part. It's kind of like a frontal cut. We're separating anterior from posterior. All right, here we are. I've drained the fluid, and we're opening up our stomach like a book. What you'll notice is at the points where we had the entrance leading to the esophagus and the exit going to the duodenum, there's the texture of the stomach is pinched in here. It's pinched in because there's muscle here. These muscles are called sphincters. This is the lower esophageal sphincter. This is the pyloric sphincter. Sphincters are really important in the digestive system because they help regulate the passage of food. We want to time things. We don't want to just shove food going down all the way straight at once. We need to take time to digest. We need to take time to absorb. Your mouth acts like a sphincter. There's a sphincter in the upper esophagus, the upper esophageal sphincter. There's a lower esophageal sphincter, then the pyloric sphincter, and then there's a sphincter from the small to the large intestines called the ileocecal valve. And then when you get to the anus, as you probably know, there are two sphincters at the anus, which you probably didn't know. There are two sphincters. There's the internal and external anal sphincters. One sphincter, the internal, is automatic, so if you can just defecate if your rectum fills up with feces. If you want to control your defecation, you can use your external anal sphincter. That's made of skeletal muscle. One other thing I want to point out with the stomach is that it's textured. It's not completely smooth on the lining. The lining is textured. It kind of has this wrinkled texture. That wrinkled texture, it's called rugae, R-U-G-A-E. Think of it like pronounced like algae, but rugae. These are folds, and the purpose of these folds is that they can expand like an accordion. As you probably know, if you've eaten a lot, your stomach can get really, really big. The reason why it can get really big, but without damaging your stomach, is because of those folds, the rugae. Your stomach not only is a place for digestion, but it's also a storage area. You might not know where your next meal is coming from, especially, our ancestors in the wild or something like that. You want to eat as much as you can before your hopeful next meal. So you want to get as much nutrients and stored away, and then pace yourself with these sphincters as you digest the food.